Welcome back. This is Math Explained, and the topic of this one is solving problems. Okay, so the whole point of math is to find how much or how many, just in general, you're trying to solve some problem that you have. It could be a problem with just numbers, but most likely it's relating to the real world, like how much do I need to invest if I want this much money by the time I retire? Well, we're solving problems. So, okay. Most of the times, like let's say you have an equation, let's say you have f of x, which is just another way of writing y, equals x squared minus 1. Okay, so that, if I graph it, looks like this. Here's my little coordinate plane. I may have drawn that too big, but that's okay. So it comes down through here. Oops, it doesn't, well, okay. We'll just pretend it touches there. Let me adjust this rather than we redraw the whole thing. Okay, so this is what that looks like, and this continues on forever, and that continues on forever. Of course, in real life it would be a lot smoother. We'll just pretend. Okay, when somebody asks you to solve a problem, what they're really wanting to have, especially if you have something like this, is you're looking for the parts where it crosses the x-axis. Those are the solutions. In this case, it's an x squared, so we have two possible solutions because you look at it and whatever your highest exponent is, that's how many solutions you could have. So we have two. So, okay, two possible solutions. So if I want to solve a problem, like I just have a regular equation, I want to solve it. If I'm looking for where it crosses the x-axis, well, at the x-axis, our y is 0, right, if you're on the axis? So then what I want to do to solve this problem is I'm going to take, so this is my y, and I want to set that equal to 0. So I am looking for the x values that make this equation cross the x-axis. So now I have 0 equals x squared minus 1. So, okay, so now if I want to solve this, I got to get the exponent, I got to get the variable, in this case our x, we got to get that by itself. So I have an x squared, so I'm going to have to get the square to go away, but I'm also subtracting 1. So I need to unravel this. Okay, we all know about order of operations, so parentheses, exponents, multiplying, dividing, adding, subtracting, so PEMDAS, or please excuse my dear Aunt Sally. And normally we do things this way when we're just working out math problems. If we're solving, we're basically unraveling. So what you want to do when you're solving is you want to go and work backwards. So we can't take the square root yet to get rid of the square because we've got that x minus 1 there. So the first thing we're going to do is we want to get rid of this one. Well, to get rid of something, you do the opposite. So right now I'm subtracting. So what I'm going to do is I'm going to add. Because negative 1 plus positive 1 makes a 0, that goes away. But I can't do that to one side of the equation without doing it to the other side of the equals. So if I add 1 on the right, I got to add 1 on the left. So now I get 1 equals x squared. Now I usually like having my variable on the left side, because you read left to right. But so usually what I'll do is I'll switch that around. X squared equals 1. So now we have a square. And in the exponent rules, we learn about how to deal with that. But basically what we know is that if we have it raised to a power, to get rid of that exponent, we take that equivalent root. So if it was x to the third, we would take the third root. But so this is x squared, so I take the square root. But I can't take the square root on one side without doing the same thing on the other side. So I'm going to square root of 1. So okay, so now I have my x all by itself. Since I take the square root of 1 and I'm the one doing the square root, there are actually two possible outcomes. I can have plus 1 or I could have a negative 1, right? Because negative 1 times negative 1 equals a positive 1. Positive 1 times positive 1 equals a positive 1. So I get two possible answers with this square root. So I have an x1 and an x2 basically. It doesn't matter which one is which. So one of them is positive, the other one is negative, and if I look on my graph, that's true, right? This is x equals negative 1, that's x equals positive 1. So okay, let's look at this on a little simpler scale. Let's say we have y equals I'm going to go ahead and put my y on the other side. Let's say I have 2x minus 3 equals y. So if I want to solve that, my very first step, I like steps, you're going to set y equal to 0, or f of x equal to 0. So now I have 2x minus 3 equals 0. That's step 1. Step 2, I want to get my variable by itself. Okay, so in this case I have two things that I need to do. I need to get this one to go away, and I need to get this one to go away. And I'm going to use PEMDAS again, but I'm going to use it backwards. I might even put a note over this, using PEMDAS backwards, because we're working backwards to get this by itself. Okay, so in this case, multiplying normally comes before subtracting, but since we're working backwards, we're going to do the subtraction thing first. So it's minus 3, so to get rid of a minus, I add. So I'm going to add 3 here, but I got to do the same thing on the other side of the equal, so I add 3 there. So now I have 2x equals 3, because this canceled itself out. Okay, so my next step is I need to get rid of the 2. So since this is multiplied, my opposite is divide, so I divide it by 2, but I got to divide it by 2 on the other side. 2 divided by 2 is a 1, so that simplifies. And we have 3 over 2, so then that's really my final answer. So x, so I'm going to rewrite it nice and pretty. X equals 3 over 2. So then step 3 basically would be rewrite answer, so that it's nice and pretty and readable. Ta-da! That's my final answer. If you're doing this on a homework question, you want to put a box around this so that your teacher or professor knows that that's your answer, because they don't want to have to look around for those things. And you're done. That's all you do. We're solving equations. A real quick note on this. If you only had, let's say you only had letters, so distance equals speed times time, R being rate, distance, rate of speed, time. So that's my basic formula, distance equals rate times time. If I want to solve for t instead, I can treat my letters just like I would numbers. So if I want to get the t by itself, right now the r is multiplied, so to undo multiplication, I divide. Gotta do it on both sides. So this simplifies to 1, and I end up with t equals distance divided by rate. So if it's an equation that only has variables, you treat it just like you would a number. Yay, hooray, solving equations.